So tolerance, what is tolerance? Write this down or highlight. Tolerance is the measurement variation allowed so that an item is acceptable for its intended purpose. Okay, very important. I would box that in maybe. It's what the industry allows. It says for a simple bookcase to a complex computer, you must take measurements. Measurements should always be as accurate as possible, right? And they should be precise enough to meet the project needs, right? That's always what you're aiming for, obviously. You want to be right on target if you can. When manufacturing a product, here it is. This is another way of saying range of sizes is often acceptable. A range means a variation, right? For example, if you're making a mortise and a tenon, that's what they're doing here, joint as shown in the diagram, the tenon needs to be small enough to fit the mortise, but large enough that it will not fall out. The range, here it is again, the range of acceptable values is called the tolerance. Okay. And let's write this down. This is a somewhat of a new word. Highlight this. Nominal value is the target value of measurement. Nominal is the target measurement. Okay. What we're aiming for. Was this the tenon? And it is the, I'm probably not pronouncing it right. Mortise, I don't know. Mortise, whatever. You get it. Okay. I'm thinking also of a more applicable example. A door in the winter time. So if you're making a door, right? If it's too big, what's going to happen? You can't close the door, right? You're going to fight with it most of the time. If it's too small, you're going to have drafts all over the place, right? The air is going to come in. So there's a tolerance there, okay? The tolerance is determined by subtracting the minimum and maximum acceptable values from the maximum acceptable. So if you take the min and the max, you get your tolerance. So I'm going to write that down. Tolerance is max minus the min. On page 92 if you. Tolerance is the max minus min. This is controversial right here. The province doesn't agree with this. The target value is usually halfway between minimum and maximum. So can you like just, this is not always the case. That is a controversial, I kind of want to scratch that, but sometimes we're going to assume that that is the case if we don't know better. Okay. And when you're working with PDFs, it shifts everything a little bit. So this kind of got butchered a little bit. But tolerance can be written in 4 ways. Study sheet. Unless you're going to remember this, you want to have these 4 ways of writing this in a study sheet. And I'm going to rewrite these 2 that got kind of, so I'm just going to go minimum plus the tolerance minus 0. I'm just rewriting what's on here, okay, in case you're wondering. Maximum, you can't get any higher than the maximum, so we go plus 0, but we're going to subtract the tolerance. And I don't know, I think we should do this, right? So you're not like, what? He said 4 ways, and why is there 6, right? So 1, 2, 3, 4 ways of writing tolerance. Why they did that, don't ask me. Like, I don't know why they didn't just decide on one. But we're going to make this work. We're going to make it work. So you're going to probably write notes right till the end today. But then I can talk about it more tomorrow. You have something to look forward to on Friday, right? Mr. Dirksen talking in the morning. Only for a little bit, guys, and then you don't have to put up with me anymore. All right. Good. Now let's do some. I'm gonna give you examples, and we're gonna work with them so you know what's going on here. Okay. And I actually worked out these examples this morning to make them. This page is brand new to this booklet. So let's look at the first one where when you have a number over a number. So we will assume that this is the format that you're given. Okay. Every time you're gonna always have the first thing that you're gonna write down as the max. Let me redo this. Sorry, I'm just looking at the space I have. Sorry. So I'm going to write this down. 15 centimeters. 15 centimeters over, let's say, 12 centimeters. That's an example. If you see that, it's like, aha, this is the max min example, right? And every time for all four of these, you can always tell me the following information. The max, the min, the tolerance, and the nominal. For every single one of these examples, you should be able to tell me all four of these. Two of them are going to be easy. Boom, you're just going to know what goes in there. The other two, you might have to do a little bit of work for. Okay? What is the max? If you looked at this, we're going to assume that that number is our max, right? Like it should be pretty obvious. So you just go ahead and write this in. If I asked you to fill in one of these, I'm like, yeah, the maximum acceptable measurement is 15. The min, we're going to assume is this 12 here. Boom, right? Done. How do we find the tolerance? Who has a good memory? What did we just read on the previous page? How do you get your tolerance, Joey? Max minus min. So I'm going to actually write this down for you, which is 15 minus 12. So there's a 3 centimeter tolerance in this case. That's what kitchen craft would have been, more or less. Like 3 centimeters. It depends on how far down the process you were. Nominal. In this case, we assume halfway point. Halfway between min and max. So this one I'm not going to ask you too often because I don't really care. In this case, we don't care about the nominal. Okay? So we're going to say that the nominal, watch this, is the max, watch this, plus the min divided by 2. We're finding the average between these two. So that's the formula. So that'll be 15 plus 12 over 2. You got to do the top first. 27 divided by 2, which is going to be 13.5 centimeters. Somewhat controversial. The province would say not always, but given this information, we're just going to assume that that's the case. So put a star on either side of this statement. I won't ask that on a test, but some of the worksheets are going to have that. Okay. Next, something like this. So I'm going to give you an example. Let's say you were given a measurement 17.5 millimeters plus or minus half of the tolerance, which is 0.4. I'm giving you nice and easy numbers here, but it applies to everything. So let's say you're given something like this. I want you to think, Mr. Dirksen told me that I can get my min. Oh, I'm mixing it up a little bit, but it doesn't matter. Min, max, tolerance, and the nominal. You should be able to answer these four every single time. Okay. So you basically always, in your study sheet, you're going to have this written, and then you're going to look at this like, oh, okay, this is that format right there. So what's this front number? It's the nominal. So watch, I'm just going to go arrow and fill in the easy ones first. This number inside is my tolerance. So that's 0.4 millimeters. I'm finishing this example and then that's it, okay? Then you can take a break. But make sure you have this example. Min, how will I get the min? Just like before with uncertainties, you take 17.5 and you're going to subtract because you want the minimum, right? Minus half of the tolerance, 0.4. So you're basically taking the statement and rewriting it here, but only focusing on the minus. 17.5. What's half of 0.4? 0.2, right? Basically, folks, this is 0.4 divided by 2. Just think of it that way. You're dividing by 2. We can do this in our heads, right? 17.5 minus 0.2 is 17.3 millimeters. And the max, 17.5 plus half times 0.4, which is 17.5 plus 0.2, which is 17.7 millimeters. So I'm going to underline those. Dun, 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 dun. To be continued.